Hey everyone, welcome to CodeStreak Daily. In today's video, we are going to learn how to construct a linked list matrix. So basically this is a common interview problem and a great way to understand linked lists and matrix traversal together. So without wasting any time, let's dive into the solving of the problem. So it's 9th of October today and the problem was already asked in fact set company. Okay, the difficulty level is easy. Now let's try to solve the problem. Okay, let me read the description here. Given a matrix mat of n cross n size, so our task is construct a 2D linked list representation of the given matrix. So each element is given here. We have a matrix n cross n size, that means rows into columns. Here we have a 3 cross 3 matrix, and the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have the output like this 1 2 3 4 5 6 7 8 9, and at the end it is pointing to null. And we also have the matrix here 23 28 23 28. It's a 2 cross 3 2 cross 2 matrix, and we have the matrix representation like this. So each element in the matrix will become a node in the linked list, and each node will have a pointer to its right neighbor and a pointer to its down neighbor. Okay, so each node points to its right and down neighbors. If there are no neighbors, the pointer will point to null. As we can see here, after 28, it is pointing to null to the right, and here also after 28, it is pointing to the null to the down. So here we have an expected time complexity of order of n square, because we will be traversing through each element in the matrix. So therefore, we will have a time complexity of order of n square here. So to construct the matrix here, we have to traverse to the right, and after we reach the last node, we have to point to the null. And when we traverse to the down, we have to point to the null when we reach the last node. So here we have a class node, and the matrix consists of the data as well as the right as well as the down. Here data consists of x, and the right and down are pointed to none. So here we have been given a class solution and a function in it, construct linked list matrix, where we have a parameter mat, that is matrix. So to write the code, first of all we have to check if there are no elements in the matrix. Like if not mat, then we are going to return none. So this is the basic condition we have to check first. And now we are going to get check how many rows and columns are there in the given matrix, that we have to check the dimensions of the matrix. So I'm taking two variables n and m, where I'm taking n equals to the length of mat, and m equals to length of mat of 0. So in this way we will get the dimensions of the matrix, that is number of rows and columns of the matrix. And now we have to create a 2D list to store the heads of linked list nodes. That means we have to get each row head separately. So I'm taking nodes equals none for underscore in range of m. So here we are traversing through the column, and another one for underscore in range of n. Okay, so now we have to create all the nodes. So I'm taking a for loop here for I in range of n, and taking another loop for j in range of m. So nodes of I and j equals to, this is here we are going to give these values to the linked list. Okay, so there's a typo, nodes of ij equals to node of mat of I and j. Okay, so we have to set the right and down pointers now. So taking a for loop again for I in range of n, and for j in range of m. So we have to set the right pointer, if not at the last pointer. Okay, so we have to check the condition if j plus 1 less than m. So in this condition, nodes of I and j dot right equals to nodes of I and j plus 1. Okay, so we also have to check another condition, that is we have to set the down pointer if not at the last row. Okay, so if I plus 1 less than n, then nodes of I and j dot down equals to nodes of I plus 1 and j. Okay, so now we have to return the head node of the linked list, that is top left node. We have to return nodes of 0 and 0. So let me run through the code again. First of all, we have a class defined node to represent each node in the linked list, and each node contains the data, a right pointer as well as a down pointer. In this solution class, we have the function construct linked list matrix, and it takes the matrix mat as an input and it converts into a 2D linked list. So uh, we initialize a 2D list of none values to store the node objects here. Here we have initialized like that, and we then loop through each element of the matrix, creating a node for each element here. And the most important part comes when we link each node to its right neighbor if it exists, and also down neighbor if it exists. So this loop does that work. So here we will link each node to the right if that exists, and here we are going to link each node to the down part if that exists. Then finally we are returning the top left node of the 2D linked list. So let me run the code and check if this works or not. Okay, there is some runtime error. Oh, okay, my bad. Now let me run the code. Okay, our output matches with the expected output. Now let me submit the code and see if that works with all the hidden test cases or not. Whoa. Okay, our problem of the day is successfully solved. There are 1115 test cases, and the time taken to solve all the test cases is just 0.12 seconds, and we have a accuracy of 100%. Okay, so that's how we have converted a matrix into a 2D linked list in Python. This approach is simple yet powerful for understanding a matrix traversal and a linked list together. So if you found this video helpful, don't forget to give it a thumbs up and subscribe to CodeStreak Daily and hit the bell icon to receive the daily updates on solving the problems of Geeks for Geek and as well as lead code. And if you have any questions, please comment on the video. Thanks for watching, and I'll see you in the next video.